understanding structural analysis in terms of with the aid of STAAD Pro. Actually, STAAD Pro is one of the engines. Okay? STAAD Pro is one of the engines for the design and analysis purpose for the building. So there are various products. Okay, so when you consider a building, when you consider a structure, so the structure is majorly subjected to lots of excitation in the sense the loads or vibration or settlement or temperature change. We can take any term. So if you consider any structure, it will subjected to various excitation. So let's say if we are standing on a place, so we are having our own weight. So we will subject it to the weight of the dresses. We will subject it to the weight of the attachment. So sometime we'll feel the vibrations. Sometime the settlement can occur. So temperature changes. So likewise, when you consider any structure which able to attract more exciting forces on that structure, when the excitation is applied on the structure, so structure is having some boundaries. So structure is having a boundary, means supports. So if we have any structure, we support it. Once we support it, it will give responses. Responses mean what are the internal forces, what are the displacement, what are the stress and strain. So it is a mathematical derivatives. So when we have a excitations as well as a response on the structure, this is called structural analysis. So if you have a building, when the building is subjected to lots of external excitation, it will create internal forces. For an example, if you look at any advertisement, so that advertisement is an external force that create interest or like that you want to purchase that product. So that is the internal force. So this is, if this phenomena applied on a structure, which is called structural analysis. So I will explain about the concept of structural analysis on coming slides. However, in a nutshell, I can say, if you consider any structural analysis, it cannot be done by manual calculation, or it cannot be easily carried out by mathematical equations by using readily available softwares like Excel or whatever, the computer calculators or whatever we are generally used in our daily practices. So we need some engines. So which need to run the analysis, or which need to respond to the analysis. So that will create results. Because when we consider a structure, it has lots of elements. When there are various elements, it has very complex matrix it will form. Therefore, we need a special engine. There are various softwares are available in the market. As you all know, the SEP 2000 is one of the software. Likewise, the STAAD Pro. So once I show to my screen, I can show you here. This STAAD Pro is one of the software, so which will be usable. STAAD Pro is one of the software which will be usable for structural design. So likewise, we have some other softwares too. For an example, you can use one of the very basic software called Procon for structural analysis, and SEP 2000 is another software we can use for the structural analysis. We have a Revit that also can be used for the structural analysis as well as its architectural software. But there are components to do for the structural analysis. Also, it has another family called Revit Robot, Autodesk Robot, which also can be used. Likewise, Strand, Midas, global, there are various softwares are available to do the structural analysis and design. However, now you have selected STAAD Pro, so you have partially interested to do STAAD Pro. So then I wanted to talk about the STAAD Pro. So what is the advantage of STAAD Pro over the other software? So that is another thing I have to explain. So it is like this. Now, Ola ultimately going to give a same results. Okay, ultimately, all these softwares need to give a same results. So all the softwares need to give a same result, such as what we need is the results of the analysis. So when we think about the structure, we need the results of the analysis, and we have to design it, and we need the results of the analysis. So our ultimate goal is results. The ultimate goal is results. So when we are talking about different softwares, why it is similar to our phone. Now we are using Samsung phone, Apple phone, Motorola phone, uh, uh, Oppo, Vivo. So those are coming under the same family. Oppo, Vivo, Samsung, all are coming under same family. But when you come to the operating system, different operating system like iOS. Likewise, when you come to the BlackBerry, it is coming to the different OS. So when the OS system is changing, what will happen? When you are using a new phone, it will take 1 or 2 days to sync with this phone. Once you sync it, that will be easy. Likewise, here we have softwares. Different softwares have different features. Different softwares have a different type of approaches. However, ultimate goal is the results. It will reveal the results. It will give the results. Finally, it will give the results. So when we think about its advantages over the other software, in Sri Lanka, when we talk about Sri Lanka, from the beginning of structural engineering, we have practiced to use SEP 2000 because in the local universities, they have uh, taught the SEP 2000 for the students in undergraduate. So when they turned to the field, so the SEP 2000 were practiced in the designs office. However, now we have access to since the technology developed, we have access to all the softwares. This STAAD Pro also in use in Sri Lanka, especially for the what do you call steel designs, especially for the steel designs. We use a STAAD Pro. Okay, or we can do the concrete design also. So we can do pipe design. We can do the type like temporary works. So for those things, because it create lots of good reports over to other softwares. So it will give a detailed report over the SEP 2000. So contractors, they prefer to produce STAAD Pro reports to submit to the consultants for the design reviews. So that is another advantage what we have on this STAAD Pro. So generally, when the people are trying to move to these Middle East countries, or the people where the Indians are saturated, so where the STAAD Pro is widely used, because STAAD Pro is a widely used software in India. So people, because very easy, no, the software is very easy. It's a software by a Bentley. Bentley is the producer of this software, like Autodesk is the producer of the AutoCAD Revit. The Bentley is the software. So also which will be used for the BIM technologies, which will be used for the BIM technologies. So this is very famous in the places where the Indians are saturated. So especially in Middle East countries, Singapore, so they use STAAD Pro in their design purposes, uh, not for the large scale, for the medium scale. So for the large scale, what I feel is not comfortable with this software, but for the medium scale, this software is very easier, because because it is like the BlackBerry. All the tools, all the keys are in front of you, so you can just click the tools and get it done very easily. Now there are other softwares too. I think nowadays you all are very aware about the advertisement of Midas. I think most of your mail will be saturated with advertisement of Midas. That also similar to the software. So that is the what I feel is that is a combination of STAAD Pro and the ETABS. So likewise, different softwares are there which has different abilities, uh, different type of applications. So what we can do is we can understand how we have to use the software. So in my point of view, before understanding how to use the software, so we have to learn the fundamental of structural analysis and fundamental of structural design, that will be able to give confidence to the user, who will be able to use any of the software whenever the requirement is exist. So that is one of the very important point you should understand. So before going to the concept of this, I will explain the software a little bit. So here we can go to the new project, and I will explain other thing later. So you can do it in any type of scales. You can see you have empirical scale and super SI, standard international scale. So yes, you have empirical scale as well as standard international scale, which can be able to use wherever you want. So once you create a structure, so you will get an interface. This is the STAAD Pro uh, window, initiating window. This is the STAAD Pro initiating window, where you can start learning or start working with the software. So start working with the software. You can see here we have lots of family attached, with the STAAD Pro. So starting from the modeling, we have a modeling here. So building planner, piping, uh, bridge deck design, results weaver, the foundation design, steel design, connection design, concrete design, advanced slab design, earthquake design. Likewise, we have various design engines, and the results weave engines are here. So here, when you look at this modeling, this is the modeling concept. Okay, it's about the modeling. In the post processing, you can see the results. In the post processing. The foundation design, steel design, rem connection, concrete design, slab design, earthquake design, these all are coming under the design principles. So that is coming under the design philosophy. Here bridge deck and the modeling become piping bridge deck modeling become analysis philosophy. This is the results of post processing, a results evaluation and reporting philosophy. When it's come to the building planning, it's like a primavera, Microsoft project. So it's actually for go to the fourth dimension. Fourth dimension is the time, no? Fourth dimension of the building information modeling. Fourth information of the building information modeling. So that is the easiness we have here, because when you create a one structure, it will be converted to any structure easily with this particular software. So look at this, all the tools are here. So once you now when you look at the first time, it will see you don't know the name of those tools, but once you used to it, automatically you will understand the easiness of accessibility of these tools. Okay. Further, when you look at, okay, when you think about any softwares, one of the very important thing is why we need to do analysis. As I told you in the beginning, so when you have a software where you can apply the load on the structure, so it will give a excitation. So applying excitation, so it can be either load or vibration or settlement, thermal change. So when we give excitation, it will give responses. So the responses have to be designed. So now for an example, let's when we look at ice cream advertisement, we can have the thirst to eat that ice cream. So the advertisement is a external load. Okay, advertisement is the external load. But however, when I look at the when I have that particular ice cream, so what will happen? It will create lots of problem. So that is the problem. So that is the responses. So what are the responses you have? When I think about the responses, we have to design it. So we have to take medicine for the responses. If you get a cold or something, we have to take a medicine for it. Likewise, when the loads are applied, so we have to get a responses for it. So that is the excitation applied on the structure to the responses. So this is the in need of structural model. Why we need the structural model? So this is the main reason for the structural model. So when we do any structural design, it is not just a modeling. So don't think that once we modeled in the computer, we are getting the results. No, that is totally wrong. You if you put the garbage into the washing machine, your output will be the garbage. So don't think that once you learn the software only, you are able to design the software, design the building. That is a totally a mad concept. So the one of the main concept is you have to understand the concept of building, understand the concept of structural think. After that, you have to use the software as an aid to make your work easy. The software is an aid to make your work easy. For an example, the phone or telecommunication device are not the very important thing for the life. So we are using those things as an aid to make our life easy. Likewise, when you think about the structural design, it is like a concept. So we have to design a concept. So how the load is transferring, what are the external load is coming, how the load will be transferred to the element. So if it is a structural structural element mean which are interconnected each other, the reason of interconnection is to transmit all the load safely to the ground. So there is a way how it is going to transfer the load safely to the structure, to the foundation. That is the fundamental concept. Without understanding the fundamental, if you model and if you are getting the results, that is not the way what we are expecting. So if we are doing like that, we don't want the human for it, we don't want the engineer for that. So that will be able to do by the robot itself. So what we need is we have to develop the concept. We have to input the concept exactly to the software, exactly to the software. So we have to select appropriate system and material to the concept. So for that, we can calculate the load, how much of load can be come to that. Once the loads are evaluated, we can do the initial sizing of member. It's just a thumb rule, guess, trial and error method. We can just guess the numbers. So there are some guidance, there are some rules, there are some method to guide you which range of number you have to select for the initial member sizing. Then you have to do the structural analysis. Look at this, the structural analysis, this part only coming with the software. Okay, here only you are going to use this STAAD Pro here. So all these things are engineering, so you have to use your basics or fundamental. I will come across all these things when I'm explaining this. So you have to come to the software at the end like this. So from the structural analysis, you will get the results, you will get the results, so which is used to design development. You have to check whether the elements are adequate or not. If the elements are not adequate, now you have to change the member size. You can change the member size. So then you can check, okay, if the member size is okay, no problem, you can optimum the size of the element. If it is not, change the member size and come back. So after that, you finalize it, you finalize it, finalize the structural design and come to the final solution. If no, if yes, go to the detailed design. So the detailed design is the one you are finalizing your design. So that is the concept we have to understand. So actually, I'm not sure today the range of qualification of the audience. The main problem, okay, I will get the details by next session after we all finalize the theme of this session. So after that, I will drive my lecture to cover uh, the audience fundamentals uh, together, or to gain the knowledge from my slides. Now this is the design process, no? So this is what I explained here. So when you look at any structural engineering design, the fundamentally we have to understand, it is not a deciding work. So you can't, it is not a good thing just call an engineer and ask, okay, so we have a column, the spacing of the column is 15 feet, so we need to provide the beam. So is it enough to provide the beam? Okay, 9 inch into 15 inches with a 2T 16 bar. So that is totally a wrong concept. Let's say someone is calling and asking, okay, we have a G+2 building, so we have a column there, is it okay to provide 40 16 bars, or shall we need to increase 40 20 bars? So that is totally different. Okay, that is that the question is wrong actually, because it is subjective. Depending on your structural modeling, structural concept, you depending on the load path, everything will change. For an example, you may have a column there for the 3-story building. Sometimes it may need only 40 12 bars. You may have a column there, it may need 40 32 bars, depends. Some people think, okay, the roof flow columns, it don't have much loads, it don't have much load, so we can provide minimum reinforcement like 40 12. So that also totally wrong, because if you, I will show you when the analysis portion comes. When you think about the top floors, due to the connectivity, due to the freedom of movement, the bending moment is very high at the top of top floor columns. So which axial force is low, however it has more bending moment, so which need more reinforcement, the requirement of the reinforcement is high.
No more sounds there, sir.
So then when you think about the structural engineering design, there are stages. So it is not just a deciding. So what my idea is, don't think that engineering can be, structural engineering can be done by just deciding method. No, that is totally wrong. So now the thing, the rules of particular agencies are changing. Okay, nowadays they are requesting a proper uh, engineers concern when you are doing any of the design. Okay, any of the design, even in the structural or electrical or mechanical. That's why, so we should understand this is a totally a concept. So the concept mean we have to combine everything. Okay, let's say you are a design engineer staying in the office and designing something by calculating very long calculation and doing a big mathematics and making a drawing finally, and sending to that construction. But the construction engineers or the person who is in the construction make mistakes, then all your effort what you have done for the design is totally wasted. So if it is a structural design, it's a whole concept, the whole package, everything to be covered, everything to be covered for the complete project, from the planning stage to the end of the project, even in the maintenance period, even in the maintenance period. So initially we have to plan, okay, what we are going to do, what is our target. Okay, what is the plan of your structure. So in the planning, it's just a desk study. So with the client, we just plan. Yeah, we just hope my sound is clear now. When the time when in the planning stage, we just sit on the desk and study. Okay, what are the problem, what are the regulation to be covered in terms of regulatory bodies, what are the constraint on construction, what are the structural materials you have to use, what is the site constraints, site conditions, soil testings. So all those things to be covered in the planning stage. From that only we have to come to the analysis stage, so where we consider the loads and responses. So here we use softwares. Then from that we get the responses. For that responses, we have to check whether the element is able to carry that load or not, carry that responses or not. So that is the element design stage. From that we have to prepare a communication detailed stage, detailed drawing, communicating method, how we are going to communicate with the site people from the design office. Then we have to specify some specification to follow, to adopt the particular design concerns. So which is the stages we have to consider when we are doing any structural design. Okay, so before going to that, I will take around 5 minute break and come back again. Okay, we'll start it back. So now, can you hear me? Can you hear me? Can you able to hear me? Are you all
Yes,
there?
sir.
Yes. Fine. Now, now what we'll do is I am trying to explain you simply what we can able to do with this particular software and how it will going to give the results. Let's think about so no need to you don't want to follow it with this, just listen or just visualize how what are the things can be done by this software. Let's say initially if you want to design one building structure, say building structure, we can give the details. Okay, what is the job? Okay, let's say job construction or proposed hotel project for, let's say, pedigree. One particular job is given. Okay, say the client is given like a Mr. Sabu. Let's say job number J1453, revision say 0, part 0, reference 0. So who designed? Let's say uh, checker. Okay, so I have given, so concept design, say concept design. So it's the initiation. So I just put a comment and this is the job information. So let's say I'm going to create a structure here. So geometry, run structural wizard. These are the tools we have here. So I can able to explain you for the detail in details later. Let's say it has a structure of 12 meter, height of 4 meter, width of 16 meter, where you have 4 and 1 and 3 bays. So each bay is 4 here. Let's say 20. Yeah, 4.5, 3, 4.5. Yeah, 4 bays apply. So this is the arrangement. So in between corridor, both side floors, and this is the arrangement. So this is the one floor arrangement. So we can create this one and you can bring it to the software. Okay, it's just an introduction to you. Okay, what are the things we can do here? So we can see the distances automatically, it will get saved. We can see the distances. So this is the dimension of this particular frame. Then say it is a concrete element, or if it is a concrete element, we can go to this general, and under the material we can give it is a concrete element. It's a concrete element. So it's a concrete assigned to the weave. So this is the perfect concrete element. Then we can say the sizes. Okay, is it clear now? Or else give me, I will try with another mic. I hope you can hear now. Okay, now you can see I just gave it is a concrete material everywhere. So here the concrete properties are there, concrete properties there. So it's a concrete material I gave for this assignment. Then what we can do is we can define the sizes for the element, let's say property. So we define the beam sizes. Let's say beam is 0.5.3 beam, and column is, let's say, 0.35 column. And so you have two beams and columns. Okay, so beam. So I can add for the beam. I selected the beam, assigned to selected beam. I can add for the column. So this is the beam and column. Now you can see the actual uh, size of that beams and column here. So the beams and columns are arranged like this. Then what we can do is now we define the beams and column. Then what we can do is we can define the load. So let's say I defined dead loads, and I define live load. So I define dead load and live load. So under the dead load, let's say uh, dead floor load of say minus 5 kilopascal. It's at 4-meter height. You can see automatically load path. I think if you can understand the fundamentals of load path, it is a two-way distribution.
So clearly, a two-way distribution will be formed on this particular uh, structure. And if you want to add the self weight, add, you can add the self weight minus one, add self weight assigned to V sign. So it's a self weight. Okay. Likewise, let's say live load of minus 3. So this is the live load. Let's say if you want to create member loads on the wall, for the wall, let's say member load of minus 15 for the facade wall. Facade wall means external wall. So I can select this particular side beams and say I apply a load of 15 assigned to selected beam assigned. Okay, one by one, oh, only one by one we can apply, but careful when you are applying. If this is applied wrongly. So we can see what is that element is. This is 26 element. You can remove it. Okay, I will explain those procedures later. So now we need to understand what we can do by the software. That is our idea. So by getting the loads from the reference and codes of practices, we can able to apply here. Then what we can do is, let's say, likewise, we have 4 or 3 stories. So you can select it, geometry, translational repeat. So you can repeat this one in Y direction. Let's say another 4 stories with the 4 meter height. Click OK. So you see, you can see in the 3D takes 4 stories. Now, self weight we applied only for that ground floor. So we can assign to all. So what we can do is there is option called assign to weave. Then Y range, I can adjust 4 to 16 meter because up to 6 floors. So all the floors, the load is transferred. Live load also on the ground, first floor only. That also we can transfer to all the floors. Okay, now it is coming to all the floors. Let's say on the top floor, if you want to remove that 15, you can just select it. So you can remove that loads coming on that top floor because there will be no any wall to be subjected at the roof floor. Change. Now you can see in the 3D, okay, that floor is not loaded by that member load. Then supports, we can fix a support. Create, let's say, a pin support at the base. Pin support at the base. So pin support at the base. Then I have to combine the load. So all the loads and everything applied. So if you want, we can produce the wind load. Command loading and load combination. let's say ultimate load combination. Let's say they load into say 1.4, let's say according to the BS code 1.4, and live load into 1.6. Right. Now ultimate limit state. Now analysis. So I'm going to run the analysis. Analysis and print. No print. And analyze, run analyze. You can run the analysis. Remember, software will not give any warning message. Software will give any error message or warning message for the human mistake. If you do any human mistake, software will not give any warning. So human mistake is subjected to you. You should be very careful about that. So it will give errors and warning message if there is any problem with the assignment. Okay, if there are any equilibrium problem, it will give, but for the mistake, it will not give. Okay, now analysis run, no error and no warning. So what we can then do is we can see the result. I will show you results one by one. So it's a post processing. Okay, post processing means I'm going to check the results. So let's say I'm going to see the results of ultimate limit state only. So look at this. This is the deformation shape for the ultimate limit state. You can see deformed. The structure is deformed. You can see the green color is a deformed shape. So if you want to see the displacement at each and every node, you can see here. If you click on this node, you can see in the y direction, it's gone by 2.33 meters. If you look at this node, automatically it will come minus 1.755 meters. Once you select this, minus 1.021. Once you select this, minus 2.192. Likewise, it will show the deformation. It will show the deformation. So this is the deflection of this particular element. We can see the reaction, support reaction. You see, support reaction. So at each and every node, what is the vertical reaction? 687, 854. So it will give you the support reaction to you. So if you now X, Y, Z, MX, MY, MZ, all those things are shown here. You can filter it even. You can filter it. You can filter it. I need only the global Y. Okay. See, you can see only the vertical reaction only. Okay, vertical reaction only. So this is the vertical reaction of each and every node. So you can take tabulation. So you can take tabulated means. This is the summary, maximum reaction. You can see where is the maximum reaction. Maximum reaction at the node number 10. Where is this? Here, look at this. This is the point. Here, maximum reaction. Where you have minimum reaction, you can see minimum Fy is the node number 4 here, minimum. Okay, we can get the values here. Further, you can get the beam result. This is the bending moments on the beam. Okay, each and every beam has a bending moment. So this is the bending moment diagram. This is the axial force diagram. So it will be very messy now. Now I can reduce the scale. So this is the axial force diagram. This is the shear force diagram. So once you look at overall, it will be mesh, but I can show you one by one separately. Shear in the other direction, torsion on the element. So all those things we can see. So let's say if you are interested to see only this particular beam, okay, only this particular beam. If you want to see only this particular beam, you can right click that beam. Okay, it has all the details. See the beam number 22. The size of the beam is 0.2 into 0.5 into 0.3. Length of the beam is 4.5. Okay, the material is having the cross-sectional area, depth, inertia, all those things are coming. Elasticity, Poisson ratio, density, alpha, concrete material. What are the load applied? So this is the dead load, live load, both load applied. Shear and bending. You can see the bending moment diagram for the dead load, for the live load, for the ultimate limit state. See, this is a bending moment diagram. So when you want to design that particular beam, you can take this bending moment diagram and bending moment and design. So that is what you want to do. Also, you can see the bending moment at each and every point. So if you move this one, you can get here distance, shear, bending. You can get the distance, shear, bending. Okay, this is the bending diagram. This is the shear diagram. Okay. Likewise, if you take a column, so that column also like the similarly, you can get the shear bending diagram, shear diagram, axial diagram, and you can see the deflection also for the beam. Deflection, you see how it deflects. Deflection for the dead load, not in the x direction, y direction, vertically. Okay, you see this is a deflection for the dead load. This is for the live load. This is for the ultimate load. If you want to service load, you have to do for that separate. So when you look at the beam, if I go to the summary, I can say which element have a maximum effect. Okay, so this element have a maximum effect. Effect means axial force. This element is having minimum effect. So for the beam, effect is not the matter, no? Axial force is not the matter. So you can leave that. Maximum effect. Which is having maximum shear. See, this beam is having maximum shear. Minimum shear. That beam is having minimum shear. Okay, symmetric. That is a symmetric arrangement. Shear in the other direction. See, maybe in the top floor. Here, top column. You see, top column. That's what I said. Top column will subjected to more force at the top. Okay, yeah. Maximum mx torsion. This column is having a more torsion. Minimum torsion. This is having a minimum torsion. Maximum moment. This column is having a maximum. Look at this, where it is coming. It's the top floor, roof floor. Minimum moment. Yeah. And the maximum mz on this beam. So now you can see the summary, which is having which are the critical elements. Okay. So you can get the critical element first. So that is a critical element. So if you interested to see, oh, I don't want this much of information. Let's say I need only a one floor. Okay. Yeah, why need on one floor? You can get even one particular bay also. Let's say I take one floor, right click, new view. So this is only a floor. Okay, this is only a floor. So let's say even you don't want that much, you need only this. Oh, no problem. You select it, right click, new view. Okay, now you are having only that particular bay. Okay. You have a bending diagram, shear diagram, everything. So you can think about only this. So for this particular ultimate limit state, okay, if you want to see the results here, yeah, no problem. Results, v value, beam results at the bending midpoint and the end point. Annotate. So for the midpoint and the end point, you are getting the result. So I will reduce the decimal. So this is very easy to weave. So if you want to take, if you need this one for your report, you can take a picture, edit, take a picture. So this will come to your report if you want that one in the report. Let's say you need axial force diagram for this particular one on the axial force. Okay, edit, take a picture, that will come to the report. So this is the overall, this one, edit, take a picture, that will come to the report. Okay. Now I have done particular analysis. Okay, this is the analysis engine. Okay, you can see if you consider this particular beam, if you go to the graph, it will give all the data of that particular beam. See? Here we have a moment diagram, here we have a shear diagram, here we have axial diagram. If you want this particular beam, yes, you can take pictures even. If you consider this particular column, okay, this particular column, results of that particular column. Here, this is the MZ. This here, this is the FX axial force. Then what we can do is we can create reports. You can see report. What you need in your report? Okay, I need input material. Okay, I need input material, job information, section sizes, what we assign, basic load case, what we assign. Okay, loads, what we assign. In the results output, I need node displacement summary, beam displacement summary, beam force detail summary, reaction. Okay. Also, if you want the pictures, here pictures, the pictures what you took are here. Automatically, it will develop report. You see, proposed hotel project for Pedyway, software license, client name, design name, the sheet number, job information, material, section properties, next stage. So these are the results. Okay, these are the photos you took. Okay. So, so you can take reports. Okay, now what I can do is, since I have the results here, I can go to the foundation design. Okay, I am taking dead load and the live load to the foundation. Run STAAD foundation. So this is the another family called STAAD foundation. So this is the STAAD foundation. You can see automatically the software will take the foundation points here. You can see the foundation point. Okay, this is the foundation point. Okay, this is the foundation point. But we didn't design it. Now we can say, okay, we have foundations. We can generate load combination according to the British code. We can create load combination and we can generate load combination according to the British code. Automatically generate load combination generate. So I'm going to create a job. I need isolated footing. Unit is design code is British. Unit is SI, assigned to all support. So I am asking every support to be assigned for this particular loads. Create job. Okay, now job is created. Isolated pad footing. Now we are going to give the design parameters. So what is the unit weight of the concrete? These are design things I will explain later. Concrete density, minimum bar spacing, maximum bar spacing, yield strength of the concrete, let's say grade 25 concrete, yield strength of reinforcement, let's say 500, minimum bar size 12, maximum bar size 20. Okay, that is done. Cover and soil, let's say drain condition, cover is 50, bearing capacity, let's say 200. Okay, water depth is not there. Footing geometry we'll ask calculate. Let that to calculate. Let the computer to calculate design. So quickly design is done. Now design engine is running and automatically it produce design reports. So for each and every footing, it create design reports. See, footing one, a complete pack of design report. You see, complete pack of design calculation by explaining the fundamentals clearly, by explaining the concept clearly, shear check, punching shear check, bending check, deflection check, everything clearly, and it will provide the reinforcement requirement. Likewise, footing 2, footing 3, likewise it will come. So this is the detailed drawing for the footing 1. So this is the detailed drawing for footing 1. So 1.6 meter wide, 50 meter cover. This is the reinforcement. 0.3 is the thickness of the footing. Pedestal column size is 0.33. That is the section view. This is the plan view. Bottom reinforcement. Likewise, we can get the pad footing 2, pad footing 9, pad footing 15, and you can get the general arrangement drawing. So this is the general arrangement for each and every place, general arrangement drawing. So you can take it into the CAD drawing and you can edit. So this is the detail, size, the calculation sheets. See, this much of information you can get it easily from this software. So this is about foundation design. It is by another type of software called STAAD Foundation. We can do a concrete design here. Let's say this is another engine, concrete RC design. I can create envelope. Let's say envelope 1. So let's say ultimate limited to design. Member, we will select and we'll ask auto form. Member, auto form members, automatically members form, see members form. So I'm going to do why we have to do the ULS design, mean ultimate design with the partial safety factor. We do ULS design. Okay, I will tell you when I'm explaining the theories. Normally we do for ultimate limit design. So now I can ask beam design and column design separately. Let's say design brief, new brief. Let's say beam 1, BS8110 is the design code. Beam, okay. You can give the details. Okay, what is the cover for the beam? What is the bonding coefficient, compression coefficient? What is the envelope? What is the what do you call grade of concrete you are going to use? What is the main reinforcement you are going to use? What is the minimum size? Top bar, let's say 12. Maximum bar, let's say 25. Bottom bar also 12 and 25. Hang gap 32, 500. Pick okay. Likewise, we can do a column design. Column 1, 8110 column. So this is the column details, column factors. Let's say it's unbraced. Let's say we are designing for ultimate limit state. So here in the brief, B1 for a brief, C1 for a brief. Here I have to say edit. Okay, let's say I'm going to design only for the ground floor. Okay, here edit M2, member 2, member 3, member 1, member 3, member 4, member 5. That means what? Member 1 means this member, member 2 means this member, member 3 means this member, member 4 means this member, member 5 means this member. I am trying to design those 5 members. Even you can see 6 and 7. Okay, member 6 is other direction. Member 7, member 8, member 9 is all members in the bin floor level, bus floor level is assigned. Okay. Likewise for the column, let's say I will take member 41 and 42 and 43. 41, 42, 43. Okay. concrete member. Okay, concrete member summary. Inputs are given. Design. Now I am going to design columns. Okay. Then I am going to design beam. Design all these beam. Beam designs are done. Now you see all the checks done. Now you can see the results of beam. Okay, M1. We'll check the results of M1. This is the layout of M1. You see reinforcement layout. So you can take this one to the CAD drawing. See top bar, bottom bar, according to the bending moment diagram. It provides layout for the beam, cross section for the beam. Okay. Then is the main layout, main reinforcement. What do you call bar schedule? Okay, this is the bar schedule. Shear layout. This is the shear reinforcement. So how to provide shear reinforcement? Shear reinforcement drawing is there. You can bring this one to the AutoCAD. Okay, the DXF file you can create. You can create the AutoCAD file. Likewise, if you want M2, select M2. For the M2, this is the layout. For this is for M2. Like you can go for M6 mean, M6, M6, M6. This is the layout for M6. Okay, so this is the drawing for it. Actually, this is the concrete design. Okay, it easily form the design. It easily form the design for this. Okay, let's go with the column design. Okay, let's say this column. It design it. Okay, so reinforcement. Okay, how many bars? 8 bars. Shear links, results, and drawings. Column drawings. See, all the details we can develop from it. So you can export, report the text file. This is actually a concrete design in a separate engine. Okay, it's also an engine of STAAD Pro. So it will make the engineer's life so easy because it makes us to develop or quickly react with the software. Is this clear? Is this clear? This is clear. So you can ask any doubt related to this. So if you have any advice or doubt, or you can choose whether your working field, whether it is advantage to you or not. You can raise any of your problems even through the chat box or even by opening your mic. So I will respond to you related to this particular course. So you can ask any Q question which respected to this. Yes. So this is the session we have initiated actually uh, to make an introduction. So this is not the session to explain the software. This is not the session to give work on experience to you. So I just give you like a show how you can able to work with this software. So uh, let tell me if you have any doubts or questions regarding. So no issues. So you don't have any doubt regarding this. So any clarification?
How do we find the load and everything?
Yes. So for the loads and everything, there are various codes and methods. So I will explain you those things with the lecture. So there is a method. Okay. So once you look at the codes, uh, you have a standard types of loading. You have standard load patterns. So that will be explained along with this. So how you have to take the load here. So that is a code related thing. Okay. Yeah, there are four. So is that normally all works are done by software and by theory design? Oh, okay. So this is we are doing by software. Yeah, it's true. But why we need the manual theory? Okay, I can say without the manual theory, if you use the software, it will be a collapse. So you should understand the manual theory first. After that, only you can use the software. So without understanding the manual theory, the learning of the software is the worst scenario. So you should understand the manual theory before we go to the software. So software is something aid. So I said it's a aid. It's a helping. Like when you are doing calculation, you use calculator. No? Similarly, software is a little bit of large calculator. That's all. It is not the total solution for the design. Okay, if we use as a total solution for the design, then Sri Lankan engineering industry will fall down to the very worst state. Okay, I think you can contact admin for the recording and those things. So any other doubts regarding this? Any other clarification if you want? I can able to give you response. I can respond to you for your problems. So actually, this STAAD Pro is a software which has various applications. Not only these, okay, not only for building. It can be used for the steel. It can be used for the bridges. It can be used for the dams, towers, shoring arrangement, timber design. So for all these things, it can be used. So what is your idea is you have to understand how to practice the software, how to uh, come up with the software. So that is very important. So I will try to explain with you, I hope 16 sessions, uh, how you can able to use this software. with that you will be able to understand.
Excuse me, sir. This
Yes,
structural and reinforcement detailed drawing, we can we convert to CAD drawing also, right?
yes, definitely.
This one is mostly more advanced from Tekla also, right?
Yeah, Tekla is a design software, no? Tekla is one of the design software. So it will give you design sheet. Okay, it will give you design sheet. So Tekla is more or less similar to the Procon. Okay, more or less similar to the Procon, and little bit advanced than the Procon. That's the difference in Tekla. But STAAD Pro is a general purpose software. There are two type of softwares. One is called general purpose software. One is called special purpose software. Actually, you may have seen another software in my window. It is called ETEP. This is a similar company developed software by the SAP 2000. So that is also CSI software. That is not the general purpose software. That is the special purpose software. That means it can be able to do only the building design. So likewise, Tekla has lot of limitations. So when you practice to this STAAD Pro, since it is a general purpose software, what will happen is you can use this one for the broad range of applications, so which will be helpful.
So can we use for bridge design also?
Yeah, it has a
Bridge
bridge
design.
deck. Definitely, most of the people use this one for the bridge design because it has a special unit load method. So there is a option called unit load method, which is specifically it's there in this software. So most of
Okay.
the time people use for the bridge design STAAD Pro.
Okay. That also is included in the lesson, in this course lesson.
No, I will specifically not explain. I don't explain. Okay, this is for the building. No, I will explain you how to use the software. So specifically, you can go with that.
Okay.
Normally, the lecture time is Thursday from 6 to 9. It is planned. So every Thursday, 6 p.m. or 7 p.m. Most probably, if you are busy, we can go with the 7 p.m. to 10 p.m. or 9:30 p.m. also. We can go with. So admin department will inform you.
Okay.
Further to that, any further doubts, further clarifications on it? So this is all for the introduction today. So this is just an introductory session about software and what we are going to cover in the course. As I said, I am going to cover. So since you asked, I can explain you. I will explain the complete use of this software. So I will explain the STAAD Pro software, how we can use for different purposes, different applications, and how we can get the report. And first 2-3 sessions, I will go with some theory portions because without that theory, it is not feasible to explain the application. So I will explain some theory portions section at the beginning. Then after I will able to go with along with the software. So that is my course content, what I can say. So I hope you may have received the module guide. So where it is mentioned what is the things to be covered in the course. So that will be covered.
Okay.
Okay. So okay, no.
So you will explain the concept and how to use of this software.
Yes, definitely.
So you will provide the software.
I think admin department will help you to install the software.
Okay. And what is the duration of this total course?
Totally, we are trying to have it in 40 hours. 40 hours mean it will be end up within 3 months.
40 hours, 40.
Yeah, 40. Yeah.
Thursday only, huh?
Yeah, only Thursday.
Okay. And at the end of this course, what is any certificate we will get?
I think they, as they have introduced at the beginning, they will provide a certificate by what is that called? What institution? Endorse. They will provide a certificate by institute called what is called distance learning education or something from the UK. UK certified certificate will be provided. It is
Okay.
there on your browser. You can check
Okay.
on the
We'll
browser.
check
It
it.
is mentioned. Okay, then. So we will wind up our introductory session today. So we will be starting our sessions from next week. So please contact the administration department for your interest. Thank you very much.
Thank you, sir.